Let's go.
Our next speaker has over 20 years of experience in structural design, project management, advanced computational design, and modeling. His portfolio includes everything from sports, structural art, and cultural projects to commercial high-rise infrastructure and aviation projects. He also has extensive experience designing and detailing architecturally exposed structural steel and concrete structures, none of which I could do. He's here today to talk about the future of AEC integration. From Thornton Tomasetti, please welcome Robert Otani.
Thank you. So there was a really good session just before about BIM, and I would say the talk that I'm going to give is a good follow-up to that, both on the sort of glass half empty and half full. So a little bit of a perspective. Whoops. I have to load up my presentation. So let me just introduce myself really quickly while it's coming up. I'm Chief Technology Officer at Thornton Tomasetti, and we do a lot of projects across the world, large scale to very small scale, and very complex projects. So we've been BIM adopters 100% since 2008. And so we were the first to one of the first firms to sort of dive into the BIM world because we saw the value and the potential value of BIM. But I'm going to talk about how some of the obstacles in how we work and legal issues are sort of are keeping us sort of from seeing that value downstream. So as I mentioned, very large firm, 1,500 people, many offices across the world. We do a lot of things, so it's not just instructional engineering. We do engineering across a wide gamut of fields, as well as we have a few very talented scientists in the firm as well. So we have structured our sort of design initiative to be the global leader of change and innovation in the industry. And with that, we've created this initiative called CORE. And CORE is an incubator within the firm that has also spun out some startups in our twin entity. I'll talk a little bit about that. And we have three different sort of vectors to the core entity, and that is the core studio, which is the everyday, which is people 100% of the time working on tools and research projects as well as very complex projects. And then we have a general R&D program that's firm-wide called Core Lab. Anyone in the firm can put forth an idea, but that idea has some legs, we fund it. And we've seen some huge gains in ROIs just from that initiative. And then we recently formalized something called Core.ai, and I'm going to show a little bit about that. We have a couple data scientists who came from our applied science practice, who have been incredibly sort of valuable in sort of creating a couple of tools that I'm going to demonstrate, one of them at least, to show the value and the benefits that AI will have on our industry. The idea of this is that the core initiative is to harness the knowledge of the entire firm and create really smart apps around that. And this is our sort of team that I mentioned that is working on this all the time. We're almost 20 people. We'll be 20 people in next month. 14 of which are software developers who just happen to learn software development and also be architects or engineers. Most of these folks are architects, actually. So the Twin Accelerator, I kind of mentioned, I'm going to go through this very quickly. It's certainly not, but it's valuable to understand that some of the IP that has been generated in Thornton Tomasetti has probably more value outside of the firm and can touch more sort of markets than just the sort of engineering field. So these are the four entities. OnScale is a multi-physics solver, just got Series A funding. Construe is an interoperability platform, fully data-centric, which I'll talk about a little bit today. Hummingbird is a tall building damper that was co-developed with NASA. and is basically half the size of traditional dampers and significantly less cost. And you're going to see a lot of those on tall buildings in the future. As well, pumpkins mounts is more of a defense industry item that sort of protects equipment from shock and vibrations. So I would argue that our industry has already been disrupted. And this is pretty evident in this McKinsey graph here. And this is when I started engineering, or structural engineering at least, in 1995. We were about, I'm going to say 100 people in New York. And we had probably 3 computers for the engineers to work on. And so it was very much a manual way of working. And we did sort of kind of half and half hand drafting and half AutoCAD for like plans. But you can see the productivity in the construction industry, of which we are part of, has not fared so well with the advent of technology. Revit was introduced in 2004. Revit adoption started in 2006, and you can see the trend is as sort of the power of BIM has just not sort of been realized by our industry. And so I'm sure you've all seen this. This is a really good graph that HOK had put together of showing how we could, as an industry, do a lot more with these very advanced tools up front to create a smarter design and then sort of do a more detailed design down the road, as opposed to trying to figure out problems along the way, and then also have less sort of impact on the overall sort of cost of the project. So this is still very true, but we still haven't seen those gains down in the construction world. So I'll say that one of the reasons is that the model of how we work is still very old school. And so, you know, this is sort of the typical siloed sort of view of how we work. And, you know, it starts with a developer, an owner who wants to build a building, hires an architect, usually is the first person or first entity that they hire. And then the architect is responsible for hiring the engineers, and then it's a very sort of linear way of working and transferring information. But there's usually, to this day, some concept level designs have no involvement with the engineering team. And you can see over 60% of the cost of a building typically is directly related to engineering. So if you don't have the experts at the table at the right time, you're already potentially going down the wrong path. Contractors, even worse. Many times they don't see the project until, you know, it's time to bid the project. And guess what? 90% of the cost, at least 90% of the cost of a project cost, is in the construction world. They should have a seat at the table early on in the process. In facilities management, I would say institutional projects is where we've ever have any idea of what the FM folks want in their project and need to maintain their building in an efficient way. So this is where we are. And it's not a good model, and this is the model that is sort of being disrupted by the Qatar's and the WeWorks of the world by sort of stringing these ideas together. And guess what? By not having all the right players at the decision-making period, the owner has the curtain drawn over their eyes, and they're stuck with potentially super, cost overruns when they're not anticipating that. So this needs to be the model. So this is just a general idea that everyone who has stake in the game, who can make an impact, needs to be at the table at the right time. I'm not saying the architect doesn't lead design, they always should lead the design, but the other experts in the field who have an impact on the built project need to be there and making decisions. So, the promise of BIM. I would say part of the problem is that the standard of care, which was developed, I'm going to say back in the 30s. I mean, I've worked on Rockefeller Center buildings, and the projects are basically literally drawn on canvas. And so the only difference is that the canvas you can't throw away very easily, right? Paper you can. So this is where we are. We have the power. We have the Ferrari here. Everything in that model, the BIM model, this is our Mirar platform, a 3D BIM viewer platform that we created. we can see all of that. We can see the geometry, we can see the material properties, we can see all the data attributes in that model, yet we're still required to give it on a 2D drawing, flatten it down into a dumb piece of paper. And so the standard of care, which was developed in the 30s, i.e. the horse and buggy, is still the standard of care today. It doesn't make any sense at all. So let's just talk about 2D drawings, right? The standard of care. This is the standard of care. You can see this is probably back in the, I'm going to say the 60s. People working away on these 2D plans. I'm using the Cornell Tech project, which I was the engineer for, now called the Tata Innovation Center, a very complex project in New York City, very successful project. We still have to submit these drawings to the building department, you know, and to the contractor for that matter. But let's talk about that. So what does a plan actually do? It represents sizes, dimensions, materials, forces, other metadata, strictly by symbology, right? Symbols, designations that this represents this in the 3D world. But guess what? We already have that. It's already in the model. We're taking a really complex thing and making it really dumb, and the dumb thing is what goes to the contractor, which is unfortunate. So again, this is the Revit platform. I click on that element. I have all that metadata, that really smart data that I'm also showing in representational form in 2D documentation. That doesn't make any sense to me. There are some things that are okay in 2D, but for this type of information, it doesn't make any sense. So this is our Construe platform. This is I mentioned the Construe platform. This is a database sort of environment. This just demonstrates this building in 3D showing that same element. So this is uploaded from Revit. We have a nice little viewer. I can hone in onto the second floor, which is that plan was taken. Spin it around. Also, you get the other advantage of 3D, which is you get the spatial sort of recognition of the adjacencies of this element and the complexity of the building and all of those things. And guess what? All that data-rich information is all embedded in the model that we can access. So again, why the 2D? It doesn't make any sense. So for building departments, we have to not, I mean, obviously they still need drawings of some documentation, but, you know, we talked to some, you know, like the Commissioner of Department of Buildings in New York City last year, and he told us the only thing that we look at is fire egress. And I was like, why am I going crazy issuing all these drawings, spending hours and hours at a time, creating a 2D set that they're just going to throw in a bin somewhere? So I would argue that as an industry, we need to create a value proposition for jurisdictional building departments, building code officials, that we're going to issue a digital twin at some point. Now, they're going to get significant value from that. Imagine the building department not only has some representational 2D drawings, but they have a 3D model, fully data-rich, that they can actually use for their everyday sort of operations in the city, as a smart city. Again, they're interested in the egress diagrams. Fine, we'll give them that. We have all of that. Safety diagrams. We have all the fire access. We have all the infrastructure, all the piping, all the things that they need as a city, as a jurisdiction to manage their city. We can give them that. And so it's not just to say, okay, let's just issue 3D drawings to a contractor. We also have to make it, give a value proposition to the jurisdictions. So, again, this is the BUILT project. I'm going to talk a little about it. The other thing is that what I don't believe in some of the programs like Revit is that the files get outdated after a few years. So the nice thing about programs like Construe is that it's fully a data-centric program. We've taken that whole 3D model, and it's basically, because it works out as a database, the representation of that entire model is we can actually demonstrate in a 3D program, in Excel. This data will live on forever. That Revit file lives on for about 2 years. Good luck trying to open up a 2008 Revit file today. You would probably need to have Windows XP and the version of Revit 2008 to open that file. So it's all there. So this is my own, this is the Rob Otani research wing here. But this goes from my experience. So if you take the orange, this is the hand drafting days. You take the gray, this is the CAD days, and BIM. So the time it takes to build a model is significantly more. I would say 2 to 3 times as more from BIM to relative to hand drafting. Now, the unfortunate thing about that also is that means less time engineering too, less time coordination. That's a separate story. The number of drawings has easily tripled. So really good example of that is the Hancock building in Chicago, multi-story, really tall building, 25 structural drawings. The New York Times building, which we were the engineer, 150 structural drawings. We made drawings because we could do it. We pushed a lot of buttons, it created drawings, it looks cool, but we lost some of the efficiencies of really thinking through the process really, really well in that process, and BIM is even worse. So that's I would call that a failure in terms of technology. That was a failure in we created more data because we could. Now, the interesting thing though is the value of the data. So the value of the data is where, so this didn't work, right? This I'm going to talk about. We can solve this issue. The issue of speed we can solve. The value of data is the treasure trove of which some of these gentlemen over here were talking about earlier today, is that this is what is really will finally give the promise of BIM some value, because now the data can live on. The data can be transported easily from the various stakeholders, and we're making smart decisions along the way. And then hopefully this will lead to construction productivity finally going up over the years. So just to summarize, the promise of BIM really needs to be the construction deliverable, not construction documents, not 2D documents, but it needs to be the deliverable. 2D is still required, details and things like that need to be drawn and need to be communicated, fine. But the model itself, we should be issuing this model. Again, the standard of care, in my opinion, needs to be changed drastically. The problem of this also is the fact that 2D is still the sort of standard of care, is that what we call the bottom feeders of the world, unfortunately, still do AutoCAD. And so we're competing as, doing crazy BIM models and everything else with firms that do AutoCAD. And that is not helping the process. In fact, that hurts the process, because then they can only coordinate in 2D, we're coordinating in 3D. So as anyone who has worked with a design team, the lowest common denominator becomes the highest value of the sort of deliverable as a team. So we need to change that. And going from 3D to 2D, the representational 2D, that takes a lot of work. The architects and engineers in the room, it's about 30% more work by just creating a nice looking 2D with all the information in the 3D model. That doesn't make any sense either. So I'm going to talk a little bit about solving speed. Really simple tool. This is a beam design tool that we created 3 years ago. Every single structural engineer has to do this. It's basically one bay at a time beam design. Traditional programs like ETABS and RAM could do this, but each one of these iterations takes about an hour if you're really good at it. Recreated this platform. It's a web-based platform. Anybody can use it. I could use it on my phone right now. That I can do any number of designs, fully designed, including vibrations, in seconds. And so I could do it at a meeting. I could do it, while I'm taking the train or something. It's opened up significant value. And we actually have some other engineers, actually like Katera, actually testing this out. So they see the value in it as well. Calm design app, ubiquitous calm design app. Something that I used to sit there with tracing paper on the table, manually trace out all the areas of, contributory areas of floor relative to columns. But because of BIM, it's made it harder. We not only have to do that, but you have to get that into a very smart way into our BIM models. So we've closed this loop of getting from our 3D model to our design spreadsheets back to our 3D model. So it does these area takeoffs, but it also does include sort of the overlays of programming, load programming, which actually is not necessarily consistent with the area of the tool. So this is a quick video. I'll talk through it as it goes along. By the way, this was also a research project at our office that has now become an everyday tool. So we start out in the Revit platform. Usually at SD, we have some sort of bones of a Revit file. We export it into a desktop platform that we do a lot of repairs. So we sort of flatten and sort of simplify the three-dimensional geometry into a sort of a virtual building representation of that BIM model. We apply the sort of occupancy areas of like hallways and retail areas and whatever the different loading conditions are. Dices and slices that floor loading really quickly, puts it into our very robust TT column spreadsheet, brings it back to the platform. Now we can view the results in the three-dimensional platform, confirm that it's okay, and then we push it back to Revit. So no manual markups, no manual takeoffs, no manual drafting, fully automated workflow, and no mistakes. Swarm. Swarm is a new app that we are going to, at our conference in October, the AEC Tech Conference, we're going to release. And this is something that, if anyone's familiar with Rhino Grasshopper, Rhino is a three-dimensional modeling platform. Grasshopper is a visual scripting platform that allows parametric design, very powerful design. The unfortunate thing is it's kind of why some people are software developers and some people are not. The people who are software developers get that very clear sort of nerdy logic, right? Others don't want to spend the time in learning all the languages and things. Grasshopper is very similar. No matter how much training we do, probably only about 5% of the engineers sort of latch on to this concept of parametric design and big design space. So the idea of this is to put that power of parametric and of design, computational design, into the everyday user. So the industry knowledge person, kind of like someone like myself who has 20 plus years experience, doesn't necessarily have the time to learn Grasshopper or become an expert necessarily, but we do have those folks. Every office has those folks. So the idea is to get that power into the hands of that designer. So that user also doesn't want to change platforms. They're usually like, they're in Revit, they want to stay in Revit, or they're in Rhino, they want to stay in Rhino. They don't want to use Grasshopper and all these other things to get all the geometries out, do the interoperability. They want something that's going to be a click of a button sort of use case. The author struggles to get their sort of designs and their computations to the user, particularly in a large office like ours. See, the idea is that we give the developer or the author a way to sort of a platform to share that knowledge across all of these different users. And by the way, because all the design computation is happening in the cloud, this can not only work for the Rhino platform, but can work for pretty much any of these other platforms. Illustrator, SketchUp, Revit, SolidWorks, Fusion, whatever. I mean, we're going to start with the Rhino and Revit as our first, probably go to Illustrator next. So this is just an idea of how it works. So again, this is three-dimensional manipulations being done in the cloud, being presented to the user who has no experience in using these tools. In this case, we're going to do a structural wireframe generation developed by a script. So purely from a massing, so all someone has to do is pick those massings underneath that sort of draped facade, move the sliders around to the geometric configuration that they're looking for, push the button, and the result comes out. Change the parameters, regen, and recompute. So again, this person who is using this has no experience in any of these computational design workflows, but they now have access to that power. This is just a further case where now we're going to do a facade geometric analysis, or generation, I should call it. So the idea is to put the power of the expert user into the everyday user. So what's under the hood here is there's Rhino put something out called Rhino Compute, which is basically a Rhino service occurring in the cloud. So we're actually calling these cloud servers, running the analysis up there, so they don't need to have any of the hardware installed. They don't need the program. All they need is a web browser, basically. Some of these get a little funky, but you get the idea. And by the way, this is multiple. This stretches across multiple sort of markets. I mean, Rhino is used, probably the #1 program used in, let's say, sneaker design, boat design, jewelry design, as well as architectural design. So it's a huge design space, and this is something that could open up that power. So I want to talk a little bit of AI. And again, I mentioned that before about how we see that we've developed those tools with the intelligence of the firm. Now, the other thing that we're actually looking into is how do we take the intelligence of the firm and put it into an app, basically an artificial intelligence app. And I'm going to talk about Asterisk, which is something that we, in a way, started 2015 about looking. I learned about machine learning back then, and I saw the power of machine learning, what it potentially could do. So we built this application that just from a massing, just from a sort of envelope of a building, can generate a full structural design at concept level in under a minute. Something that a team of engineers would take 2 to 3 weeks. So I can do one iteration, one design in under a minute that most engineers would take 2 to 3 weeks. With the embedded intelligence of engineers in the app. So this we released last year, released it internally last year. We have opened it up to some collaborators. The second highest user of the app is an architect from KPF. And he keeps saying that, I'm only playing with it, but I don't know, 300 times using the app is quite a bit. So we may send him a bill pretty soon. But anyway, it's calculating for, right now, steel building. We're changing some of the geometric parameters, floor to floor heights, changing to concrete, and it's recalculating. So beams, columns, slabs, floors, core walls, core bracing, and foundations in under a minute. And then we have a way, everything's cloud-based here. We're storing all the results in the cloud, and then having a nice sort of robust data visualization so we actually know that it's doing the right thing. And then we have a method of comparing all those options so a designer can pick and choose what metrics they're looking for from an optimization standpoint. So we showed this to architects, and it's funny because most of them don't know what to do with it. It's beyond the sort of realm of what's normal. And so some of this, sort of artificial intelligence is going to be training people how to leverage real significant computation. So I'm going to talk about delivery. Delivery, I think I mentioned, doesn't make any sense right now, but there are some really good examples where it has made sense and it has made huge dividends. So 2016, we did this project with Shop Architects in Miami, which is still there. It's in the Jungle Plaza district of Miami. It was only supposed to be there for 6 months. It's now 3 years, still standing. It's made of plastic. Branch Technology, startup 3D printing firm, additive manufacturing firm was the fabricator. We had 3 weeks to design this thing, and that in itself was innovative. But I think what is really was the real demonstration here is that we never issued any drawings. And we had a full-scale project, Pavilion, fully customized, and it was installed by a bunch of architects with zip ties, literally, in under 2 days. 2 of these, there's actually 2 of them. And so that was like, this was the first project that we worked with them on and showed the sort of power of 3D printing technology, but also the digital workflow of communicating in a single platform. The second one was, this is the largest 3D printed spanning structure in the world. It's called One City. It's in Nashville, Tennessee. This one's obviously a lot bigger, a lot more parts, a lot more computation involved, but again, full-scale project. I mean, this thing will fall down. It won't hurt anybody. It's so light. The particles that actually create the ABS, it's called, is very weak, actually. You can break it with a finger, literally. So that's why the engineering part was significant in this. And this is a quick video of the process, which we submitted this for a paper at the International Association of Shell and Spatial Structures Congress a couple years ago. So we started out with a very sort of, I would say, generic pavilion style, went through significant engineering iterations. Again, this is using Grasshopper, by the way, of both topology optimization, form finding, variations of the above, to come to a design that could be constructed fast, but also, this is a permanent structure, by the way, so ice, wind, snow, and wind, it had to be delivered, resist all those things. And you cannot do this without computation, I can tell you that. Again, trying to do this by hand, forget it, it's not done. Similarly, we didn't issue any 2D drawings for this. All 3-dimensional issuance, client super happy. And it's really not that you're going to have these every day, but it sort of demonstrates how powerful if we sort of have a correct platform for design, delivery, fabrication, and construction, that you can actually do things that are sort of way beyond the sort of norm of traditional construction. And so, again, just the people who worked in the factory put this together, no special training, everything fit together like a glove. And so, huge success there. I'm going to talk about advanced project delivery. I'm going to show some large-scale projects where we've seen the sort of the methodology of how we deliver and how we communicate the design all the way through fabrication and construction can have significant gains, again, without the issuance of 2D drawings. So we've coined the term advanced project delivery. The concept behind advanced project delivery, you take the traditional process of these handoffs along the way, and you sort of compress all of those phases with obviously with smart people in doing this work and engineers working together very closely. So steel detailing, it shortens the schedules considerably if we actually get the fabrication engineers working with the designers and the structural designers, engineer of record, at early phases to sort of build in the intelligence of their design and get their design thinking sort of built into the constructed project without saying the typical way, which is you issue them a set of CDs and hey, by the way, you got 2 weeks to bid the whole project, right? Which is almost unfair. So we believe that this methodology actually de-risks the project. So if we, being smart engineers and architects, can embed our intelligence all the way through, then we actually de-risk it. If you leave the interpretation, huge interpretation from 2D to the contractor, that's significantly risky. So this is an example project in New York City, 1.75 million square feet, I believe, where we did this project. We did it that with the advanced project delivery methodology. And this is coming from the owner, not from us. 8 months saved from the overall schedule. Now, I don't know, 1.75 million square feet of leasing is a lot of money. So value proposition, it's a no-brainer. In a way, I wish our fee was sort of leveraged against that. But that client will not go any other way now. So it took a really smart client to do this, but we see this is the way, the future of how we do how we do work. Thank you. I think there's some time for questions, if anybody has any questions. Yeah. That's a great question. The answer is yes. We have a, and it's a firm-wide effort, I would say. It's not just designers. It's the CFO, it's the CIO, it's engineers and architects in the office. We're a business, so it's not just engineering data. It's also finance data, tying those things together, making sure that we have the right people assigned to the right projects. We learn from our mistakes, and potentially find trends or some nuances of a project from past data that we can learn from. And so it's a bigger issue, I would say, initiative. But I think the promise of AI needs that data, and so we got to start somewhere. And to your question about the apps, the answer is not yet. Construe is probably the first one that is sort of a purely data-centric application. But in terms of the other apps, we have the ability to do it. We just haven't done it yet, but I think we're going to do it. So the beam design thing can then inform, the asterisk tool, for instance. And some of those swarm apps can do the same thing. So, I think the reason why AI is now very popular is because computing is a lot more powerful than it was 15 years ago, let's say. I look at my computer that I had in 1995, the Windows 3.1, pretty sad. But today, with NVIDIA and really powerful processors, there's a lot that we can do. Any questions? Oh, yeah. Yeah, that's a great question. I've been thinking about that, and I think that there is a little bit of risk. I think that, let's say, it has to start from the owner. I shouldn't say that. It has to start with at least two players in the process. So an engineer and architect can do it. We can do a fully data-centric way of working. A subcontractor and the engineer could do it. We can do it. We've kind of demonstrated that in that process. And so there needs to be, look, the subcontractors out there know it. It's just that again, the structure of them getting 1,000 drawings and having 2 weeks to get a bid out is not really fair. And so they get it, and so it's going to take, I think, a partnership and of taking, a certain risk. And again, I don't think it's a real risk. It's just a risk beyond, let's say, the standard of care. But it's going to take people to do it, which is why I'm talking about it. I actually want, my next step is to go to New York City Department of Buildings and say, hey, we have this proposition for you. We don't want to issue the same 2D drawings anymore. We're going to give you a 3D model that you can use forever. I think the biggest risk internally is not that we won't. I mean, we'll always do a good product. You know, like it's like if someone doesn't know a tool, they'll do it manually. They'll still have a good product at the end. They'll just take too much time doing it. So the risk is, at least internally, that we have so many tools now that we need to make sure that everyone's using the proper tool at the right time. And I also have seen, by the way, and I don't know if anybody else has seen it either, but it was particularly to the engineering industry, is that, you know, kids who grew up using Nintendo like playing these games, like playing with software. And some of these sort of, you know, the old school sort of inherent engineering knowledge of doing hand calculations and understand the answer before they dive into a computer program has been a little bit lost. So I think we need to gain that back. I don't see, again, if you do it smartly, I don't see the risk in doing 3D delivery and deliverables. Yeah, in the back there.
Your New York City example, how do we monetize that 8 month savings to the firm? Like that we get away from the industry simply competing on fee and start competing on value?
That's a great question. You know, I think it's going to take owners like that to, and when they have, by the way, they have sort of spoken publicly about that project, that project and how it's went. And so it's going to take people like that, you know. And by the way, I should mention that we recognize that that whole service of us doing the fabrication work, we saw the opportunity, I think, Tom's in the audience, I think it started in like 1989, believe it or not. It was Chicago Bears Stadium when the time schedule was so short that we had to do fabrication drawings directly from our engineering drawings. At the time, it was called X-Steel. And what? 2001. Right. Yeah, 89. They might not have a computer back then, but okay. So 2001 was the first time we realized it, and we've been doing it ever since, essentially. And we have a whole construction engineering team that does that. So that's also a huge opportunity. Those are fees that we would have never gotten if we were a traditional structural engineering firm. And on that project, that tower project, we were not the engineer of record. We were working directly for the fabricator. And you know, you talk to most fabricators around you know, they hate to do the shop drawing part. It's their worst sort of. They need to keep a full-time staff to do shop drawings. You know, we have the people that can do it, and we like doing it. So it's sort of a no-brainer for us. Any other questions? All right, thanks very much.
Hey guys, just a quick programming note. After lunch, we're all going to be back in here. We were going to have a breakout session, but instead we're all going to be back in here. It is time for lunch. If you can get back in your seats by 1:55 or so, we're going to start right at 2 p.m. So enjoy.